Now this is our schematic for our motor. This is here we have an Amazon motor, and we have an ESC, and the ESC is meant to control the Arduino over here. So an ESC has a specific function in arming the motor. It arms it, which means that it makes it ready to receive an X amount of voltage. So what it does is typically it'll arm when the throttle. Typically, an ESC will arm it when it gets minimum throttle, setting it for a second or so. Some controllers are programmable to adapt to this, but it really depends on the ESC. Our ESC is not like that. You have to code the ESC to have a specific function for arming it. Example maybe to arm times with different pulse widths or different speeds. The ESC is critical in the function of this motor. So when the ESC comes in, it has 6 different wires. It has 3 blue wires, a set wire, like one in the middle of like white, red, and black, and then 2 ones on the side are black and red. The black and red ones are supposed to go to 12 volts. And these are the phase wires. The 3 wires I'll get to in a second. Okay, so the blue wires, they attach to the motor directly. They control the phases. The red wire and the black wire here, like the thick ones, they are actually meant to control the ESC. Now, if you're wondering why the ESC and Arduino run off different power supplies, it's because the ESC takes different amperage than the Arduino does. So it needs a different power supply. It needs a 12 volts. As for the Arduino, it is powered entirely differently. There's 3 wires here that connect the three wires over here, the black, red, and white ones. The red one goes nowhere because it's set up that way. It's supposed to be like, it's kind of like push button. The black wire goes to ground and the white wire goes to 9. The white wire goes to 9 because 9 is the digital output we need. From what we do there is we have our code. I'm sorry, I forgot. So my servo attaches to 9. Void loop. We give it speed. The speed will sweep from 0 to maximum speed in 20 seconds, and then it will have a set speed, and then it will delay for 1,000, and then it will sweep down to 0 speed, and then have a speed 95 for greater than 0. And then have that set speed, and then it'll delay 1,000 again, and the set speed will be 0. And what it does is it's changing speeds. The ESC needs them in change speeds, like map and angles, in order for the phases. Now, the motor itself, it has a series of numbers on it, which we got D, 28, 22, 12, 1, 4, 5 kV. Now this is important in controlling and understanding the motor itself. This number is just for serial reasons, but this is the diameter of the motor. This over here will be the height of the motor. This is the number of wire turns inside the motor. That is critical depending on how much amperage it could take. And over here we got number of rotations per volt. So we got 1450 rotations per volt. So if you had 12 volts, or even better, we had say 10 volts, you would have 14,500 rotations per minute. It's pretty fast. All right, and essentially this is how we controlled our motor. And if you want to see how it works, we have a video for it. So check that out.
We'll put the video in the description below. And just remember that example right there is just an example, not the actual motor that we used.
Yes, this is not the actual motor we used. It is an example to show what the numbers mean.
All right. Thank you.